Hello, it's Duncan. Today we're going to see how to use JUnit to run the same tests against both a real and a fake server to check they both behave the same way. We're going to look at contracts. We're in the middle of quite a long story here, displaying item price. And the problem is that we have to talk to external servers that are beyond our control. They're owned by third parties. One of those parties is ValueElf. So we went ahead and wrote a client to talk to their server, and on the left-hand side are our tests for that client. Now we wanted more control than their test server would give us, so we wrote our own fake version, and that's down here, that fake ValueElf roots. And to help us write that fake, we wrote some tests for it. Here they are. And unsurprisingly, they look quite a bit like the tests for the actual ValueElf because we want the same behavior. In fact, we want the same behavior so much that we should probably have the same tests. So let's work out how to test both the real ValueElf and the fake ValueElf with the same tests. What I like to do in these cases is just make these things as similar as possible, remove the duplication that we can, and just keep running the tests. The problem here is that we only run this test sometimes, so I'm going to comment that out for now, so that we always run the tests when we run all of our tests. And let's run all of our tests. Okay, so now this URI and this URI are different, but these items seem to be the same. So we should be able to replace, if we make these non-private, we should be able to use an item in here and a not found item in here, getting rid of these. Run that. And now these two tests, this one and this one and this one and this one, are, we can see, the same, but for this invoke, and we know this invoke doesn't really have to be there. So let's make them look exactly the same. Run that. Now we're going to extract a common superclass, and we'll take it out of this one, I think. So we'll say extract superclass. We'll put it in here. Now you might call this abstract ValueElf tests, but a nicer name I think is ValueElf contract. It's what we expect ValueElf and our fake ValueElf to do. And we're going to pull these two functions up into that. So let's do that. Having done that, we can see that the contract relies on there being a client. Now we could make that an abstract property, or I think better, we'll make it a constructor property. We say we need one of these in there, but we don't know what it is. And now these tests can pass the client up. And in order to do that, we have to make this URI a little more static. Let's try that. What's happened here is that IntelliJ has tried to run this test, but can't create one. We solve that problem by making this abstract and try again. Okay, we're getting there. Now let's take our fake ValueElf tests and do the same thing. So if our fake ValueElf tests were a ValueElf contract, then we need to supply the client, and we know what the client is. It's here. What about our roots? Well, these are all stateless, so we can, again, make them static. Let's run that. And then finally, these two are going to be inherited from our superclass. So if we were to run this on its own, we'd see that we're actually running more tests than we need to. So let's get rid of these now. Now we notice that we have this test here that returns bad request for invalid query strings that wasn't in our original ValueElf tests, and so hasn't been pulled up into the contract. But this is a test for our fake server, and we want our fake server to act like the actual server, so it seems reasonable that the actual server should behave the same way. Let's find out by moving that up into our contract as well. So we'll take this and move it here. Now, in order to compile, this is going to require two things. It's going to need this URI here, and it's going to need roots. We'll provide the URI as a parameter to the constructor. So we're going to say, as well as a client, we need a URI, which is URI. Now that will be in here. And now this is not going to compile, so we can pass it in here. Well, that's confusing. Let's make this private and call it test URI. That's that one. So in here, we've got the same problem. We need to pass in a URI, and we've already got one of those lying around. So we can say URI equals a URI. Let's try all of our tests again. That's nice. So it turns out the ValueElf test server does respond in the same way as our fake server. But wait, what are these roots here? I said we were going to need to pass them in, and we don't seem to be. They turn out, in fact, to be the wrong thing over here. I think we're going to make everything private. And now we can see that this can't compile, so we need to pass roots in to our contract. What are these roots? Well, let's have a look at the type. It's a routing HTTP handler. And in fact, the only real thing we need in here is HTTP handler. So let's add ourselves an HTTP handler as well. Now in here, we know what these are. But what about down here for our ValueElf tests? We need an HTTP handler here. The answer is that all we need here, because we're talking to an outside server, is an HTTP client. HTTP 4K's HTTP client implements HTTP handler. So we can say roots is an Apache client. Let's check whether that all makes sense by running the tests. Well, it's a bit of a mess, but it does pass. Let's try and remove some of the scope confusion we've had by moving our contract out into its own file. So we can take this and we're going to say move it into ValueElf contract. Right, let's go and have a look in that file. And now that we have it, that's as good a place as any to put these two properties that are common between the two contracts that use the test. If we now go back to our ValueElf tests, we find there's a bit of hidden duplication here. And that's because this ValueElf client here, if I inline it, you can see that we have exactly the same shape of code in our ValueElf tests and our fake ValueElf tests. That means, in fact, we can pull this creating the client up into the contract. Let's do that. So we'll take this and move it into here. And now this needs the URI and the roots. That means we don't need this. We don't need this. And we don't need this. And we'll check by running the tests. And finally here, roots is not a great name because it's roots in here, but it's in a client in here. What they have in common is that they are an HTTP handler. So let's rename that to be handler. And now in the contract, you can see that we're using the handler to process the requests. IntelliJ has, as usual, lost static imports when it did a refactor. So fix that. If we now look back at the fake tests, we can see that there's an extra test in here. It's actually called server. That's a bit strange because it only tests one of the cases that we get 609 if we invoke on an item, but it tests it in a special context, the context that we are actually running a server and with a special client, one that's actually talking HTTP as opposed to talking in process. We'd really like to run all the tests in the contract against our fake server that way. So let's create another test using that contract. We'll do it in here and we'll call it fake ValueElf HTTP tests. And that is, again, a ValueElf contract. What should we give it? Well, we know the URI is unchanged, so we'll use that. But the handler now, instead of talking directly to the roots, is going to talk via an Apache client. Can that work? Let's try running it. Well, it doesn't, and it doesn't because this test hasn't started up the server that's actually required to talk through the Apache client. So let's add in the code to do that. We're going to need this server for every one of these tests, and then before each, we need to start the server. And after each, we need to stop the server. Let's try that. Brilliant. And now that allows us to get rid of this test here, but we probably want to disable all of these tests unless our system property is true. So I'll take that out of there, put it in here, and then all of this can go, replaced by now a whole batch of tests against our actually running server because of this contract. Try running all of our tests. Good. But all tests won't run this one. So we'll do that by hand. And that works. And we should re-enable this over here and run this one by hand. Good. So now our fake ValueElf HTTP tests have the situation we talked about in our last episode, where each test allocates resources, in this case opening this port, that need to be disposed of before we finish. In fact, given that our server is stateless, it's a shame to start it every time we run these tests. So we can do that in a companion object, moving all of this state into there. And then this is not before each, but before all. And this is after all. Let's run that. Now, our aim was to start the server only once, but this doesn't work. Why not? The answer is these haven't been called because they aren't static, and JUnit needs them to be static. So we have to mark these as JVM static. Try that. And we're back in action. And you'll see now that Undertow is only started once, which means it's run quite a bit quicker. So quick review. It looks as if we could inline this test URI here. In the fake ValueElf tests, we have 2 tests for the price of 1. We can run all the tests against a fake ValueElf in process, and we can run all the tests against a fake ValueElf out of process, running up server. Finally, looking at the contract, this is the place where we express all the commonality between our tests, and in fact, all the commonality between the actual version of ValueElf and our fake version. I think you can trust me to commit this while you take a break. And next episode, I will come good with my promise from last episode to look at a different relationship between fixtures and tests. If you'd like to see that episode, then please subscribe. And if you've enjoyed this, then I think you'll enjoy the book that I wrote with Nat Price called Java to Kotlin, a Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.